So let's continue on to the back of this page. When I choose my method, I'm going to use tabular, but if you want to choose the other way, feel free to do so. It's whatever you're more comfortable with. So again, remember, we're picking U, no matter what method you're choosing. Pick U based on Lyautey. So algebraic comes before trig. So when I pick my U and my dv, U is going to be 2x squared minus 3, and dv is going to be cosine of, I'm just going to write x over 4 instead of 1/4 x dx. So taking derivatives of u gives me 4x, and then 4, and then 0. Integrating cosine, remember you've got a u sub going on, and when u is 1/4 x, du is 1/4 dx. If you need a 1/4 in here, you're going to need a 4 out in front of the antiderivative. All right, so the integral of cosine is sine of x over 4. And then that pattern will stay the same. You're going to have another 4 come out, so it's going to be 16. Is it positive or negative? The integral of sine is negative cosine, so negative 16 cosine of x over 4. And you need to do one more round. So the integral of cosine is sine, no sign change. We're going to have another 4 out here, so minus 64 sine of x over 4. And then we put our signs out here. I put little circles around these just so I don't get them confused, especially if my work is scrunched together, so I don't get them lost or confused. And then I connect my diagonals and I loop around. So this answer should be, let's see, positive. I'm going to put the 4 out front. I don't think I'll distribute it through. You can if you want to. But 4 times 2x squared minus 3 times sine of x over 4. It's the first term. And then we have negative 4x times negative 16 is plus 64x cosine of x over 4. And then we have positive 4 times negative 64, so that's negative, 256 sine of x over 4. Technically, there's a minus integral of 0, blah, 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 but that's just a 0 term, so I'll write plus c. All right, so that whole thing is my answer. Yes, I could simplify a little bit. I might have some like terms, the sine of x over 4. I wouldn't go through all of that unless I was searching for my answer in a multiple choice. All right, now 5 is a little different, and you're going to run into this with 5 and 6. They're similar problems. You can see they both have an e to the u, and they both have a sine or a cosine to the u. So these require kind of a trick, but we're going to start off the same way. So I'm going to use tabular method, and in the Lyautey, trig gets picked before exponential. So when you're assigning u and dv, trig has to be the u, sine of 5x. dv has to be the exponential. I say has to be. It doesn't have to be that way. I think on these you could do it the other way. It's just I think this is easier. I haven't done it. I haven't switched them around for a long time, so I don't remember if that's a lot longer or if it's similar. All right. Well, when I take derivatives of sine, I'm not going to be able to get down to 0, but I'll know when to stop when I get back to a sine of 5x. All right. So the derivative of sine of 5x with chain rule is 5 cosine of 5x. The derivative of this with chain rule is going to be negative 25 sine of 5x. So as soon as you get a sine of 5x back, you're finished with taking derivatives. The integral of e to the 2x will require some u sub. Since u is 2x, you're going to have a 1/2 out in front. The integral of e to the u is e to the u. So 1/2 e to the 2x. And then same thing will happen again, but now it's going to be 1/4 e to the 2x. And we'll stop there since we're out of lines. And then I assign my plus, minus, plus. Connect my diagonals, loop it around. Let's see what we have so far. And for this one, it's going to be important to write it on the same line as the integral to see what's going to be happening. All right, so the first term is, I think I'm going to write this as e to the 2x over 2 times sine of 5x. And then let's see, we have a minus 5 times 1/4. So how about minus 5e to the 2x over 4 cosine of 5x? And then remember, the last loop here is an integral. So we have negative 25 over 4. I'm going to pull the constant out in front. Times the integral of, what do we have left? We have e to the 2x. We have a sine of 5x. And dx. All right. Well, what do I do at this point? When you get to a point where you still have an integral, you're supposed to solve the integral. Well, this requires integration by parts again. And if you notice, I'm going to have the same thing, right? Like u would be the sine of 5x, and dv would be the e to the 2x. And I would just kind of keep going around in circles if I just did integration by parts again. But the reason that we stopped taking derivatives when we got to sine of 5x was because, if you notice, on the left side of this equation, you have the integral of e to the 2x times sine of 5x dx. And on the right side of the equation, you have another integral of the exact same thing, just has a different coefficient out in front. So to really simplify this idea, basically you have a 1x on this side, and you have a minus 25/4 x on this side. And you can combine those like terms. Get your terms on the same side. Let's add 25/4 times the integral of whatever over to the left side of the equation. So 1 plus 25/4 is 29/4 times the integral of e to the 2x sine of 5x dx. That's kind of our little trick that we don't have to do with the other types of problems. So what do I have left on the right side? I have e to the 2x. Maybe I'll put these up in the numerator. I don't know why I keep switching how I want to write my terms. It doesn't really matter. Minus 5e to the 2x cosine of 5x over 4. Okay, what am I trying to do? Your goal is to solve for the integral of e to the 2x sine of 5x dx. So you're trying to isolate it, and you know it's solved for when you don't have any more integrals over on the right side. So all I need to do is get rid of the 29/4 by multiplying by 4/29. Every term on this side gets multiplied by 4/29. So my final answer is this 4 over 2 will reduce. So I will have 2 e to the 2x sine of 5x over 29 minus, those 4's are going to cancel, 5 e to the 2x cosine of 5x over 29. Or I could have put it all over 29, whatever. But that is my final answer. Oh, plus c. After all that, don't forget a plus c. This is not a definite integral. All right. Now, it says try the other method, but I don't want to because it will take longer. So if you want practice with the other formula, go ahead. But for this video plus the first video, I know that I might be running over a regular class period time. So, all right. So let's do this one. Same idea, just different values, and a little bit easier because you just have an e to the x. All right. So u, using my tabular method, u and dv. U has to be the trig, and dv has to be the e to the x dx. I'm going to take derivatives until I get back a cosine of 2x, which should happen after on the third line here. So the derivative of cosine of 2x is negative 2 sine of 2x. And then derivative of that becomes negative 4 cosine of 2x. So we got back there, so we're done. And this is easy. The integral of e to the x without any u sub required is e to the x. Same thing here. Plus, minus, plus. Diagonals, loop around. Keep it on the same line. Again, you do this anytime it's an e to the u and a sine or cosine to the u, basically. All right, so this term becomes e to the x times cosine of 2x. And then we have minus negative, so plus 2, I like to put the e to the x out front, so 2 e to the x sine of 2x. And then this last part's an integral, right? Minus, we have a 4, times the integral of e to the x cosine of 2x dx. And you don't want to do a whole nother round of integration by parts because this is the same thing you have up front. So again, we have these like terms. I can add 4 times the integral of all of that to the left side. 1 plus 4 is 5 times the integral of e to the x cosine of 2x dx. What did I have left over here? I just had an e to the x cosine of 2x plus a 2e to the x sine of 2x. And finally, last step to solve is to divide by 5. I'm going to rewrite the whole thing. Plus c, almost forgot it. All of these are indefinite integrals, so we have a plus c. I'm trying to remember on the homework. I better just look at it. Oh, a couple things I want to point out on the homework. First of all, do we have any definite integrals? Let me look. Those are all indefinite, indefinite. Here's one. If you have a definite integral, your process is still the same. It's just instead of ending with plus c, you are plugging in numbers and evaluating. So try that. If you get confused, obviously check my answer key. Most of these are indefinite. You'll also notice on my key, I did almost every problem using both methods, using tabular method and OOV minus integral of voodoo. Now, obviously, the formula tends to be longer, but in a lot of cases, whether you start by the formula or start by tabular, the work ends up matching up. So let me find, so like here, for example, on 17, when I did tabular, I got to a place where, get rid of all these arrows, I got to a place where my work matched exactly this line right here with what I did. So I have just same work as other methods. So once you get here, find that line, and then this is where I carried on. I wasn't going to write it out twice. So just as you're looking through that. All right, that's it for today.